So some of you have asked about question 38 because it's a chi-square test for independence, and I know the one video is the goodness of fit test. So I'm going to make an example of the independence test so you can see that. So I made up a problem. 35 men were observed during a 60-minute period of time. 19 of them picked their nose. So 19 picked their nose. That means 16 did not out of the 35. And of the women observed, 13 of them picked their nose. That means 39 didn't. So that total is 52. So if we add going down, we get 32 and 55. Both of these should be the same, adding up to 87. So there's 87 in our group. N is 87. Okay, so it's plenty big for a number. There's 4 cells. 4 times 5 is 20 should be your minimum numbers. 87 is plenty big. To get the expected values, you can do this on Excel using a formula equals, and the expected value is the row total. So I put a parenthesis there. The row total times the column total, or the column times the row, either one, divided by the overall total. And that's a probability thing. That's what all those fractions are in the example there. But you can do it on the computer. It helps a lot. So for women, it's the row total, put a parenthesis there, times column total divided by overall total. And then for the no pick, it's the row total times the column total divided by overall total. And for the women no pick, row total times column total divided by overall total. If you want to check these should add up to 32 and 55, just like they did there. I'm not going to check it. And so then you can follow these steps. You can put your observed values and your expected values. Make sure you put the same corresponding values. So 12.9 is the same value as the 19. So the value that goes with 16 is 22.1. You can put more decimals if you want. The one that goes with 13 is 19.1. And the one that goes with 39 is 32.9. So what chi-squared does is it says this is what we saw, the observed. This is the expected. This is what we should have seen based on the proportions of men and women, and so we're looking at that observed difference. It's kind of like a variance. So again, you can use your formulas: observed minus expected. Drag those down. They're all the same there. And then we want to square that number. Those are all going to be the same. And this last one's the most important. It's the column we just did divided by the expected value. And so you can drag that down. The sum of those values is our chi-squared number that we compare to the critical value. So the critical value I know is like 3.841 on this one if you look at the table, because there's 1 degree of freedom. So this chi-squared is bigger than that. So we would reject the null hypothesis, being that, I didn't say it initially, but that gender is independent of whether or not you pick your nose. So we would definitely say that gender is not independent of nose picking. So if you want to set up that way, I also put a link to a website that allows you just to enter this table and get the chi-squared value if you want to use that. So you're welcome to do either one of those technology things. If you want to set up your own spreadsheet, you can. This is a little different than the goodness of fit.